Hello everyone. I hope you guys are doing great. Today, in this video, I'm gonna talk about all the necessary concepts you need to know before starting Lab 4. So let's start. In this Lab 4, we are gonna use a very fun sensor that can help us to calculate the distance from point A to point B. The sensor we are going to use in our lab, we call this LiDAR or TFmini Lidar. So a LiDAR sensor is basically a kind of sensor widely used in automobiles. And that sensor, continuously uh, send some waves, as you can see in the right-hand side of the picture. It continuously sending some signals, and if any object, are fallen in the range of that waves, it can detect the distance. So it use the concept time of flight principle for distance measurement. And the sensor is very efficient in terms of low power, and it is designed for high accuracy, sensitivity, and speed. And also it is capable of measure distance from 10 centimeters to 12 meters. So yeah, it's a pretty well-balanced sensor, as we can say. And the most important part of this lab is that this sensor we are going to work with, it supports both UART and I2C communication interfaces. Um, as we are already done with our lab 3, so in lab 3 we saw how we can utilize the UART to communicate from our computer to the microcontroller. So now this sensor is also is capable of making communication, creating a communication channel between the UART and itself. Now, before jumping into the code description, uh, you have to understand the data format of this sensor. So uh, what does this, what this sensor does, it has a communication port, serial port, and it continuously send the data from that serial port. Now, uh, as we are know how the UART can receive or transmit data in a serial manner. So this serial port of this sensor can send data byte by byte. So as you can see here in this table is directly collected from the manual of this sensor. And so this sensor frequently send total 9 byte and then again send 9 byte and so on. So it is continuously sending 9 byte and from the serial port in each time period, it send byte by byte and total 9 byte of data. So from that 9 byte of data, we don't need all of the informations. For our lab, we only need to collect the data from byte 3 and byte 4, because as we are measuring the distance from this sensor, and byte 3 and byte 4 is the the data field that basically telling us the distance from that sensor to some object that we are trying to measure. Byte 1 and byte 2 hold a fixed value of data to kind of, you can think it as a start bit. So byte 1 and byte 2 is our start bit, and next byte 3 and byte 4 is our actual data field. From there we can calculate, or we can take the data as a distance. Now, why it is passing the distance as a 2 byte. As I already told you, it is following a standard protocol of serial port. So it can only send 8 bit of data each time. But what if we just only use, for example, byte 3, that is the distance underscore L. So here, this to field is basically used for represent the unique distance, and we are measuring the distance. As a 16 bits, because we know 2 byte is basically 16 bits, and the first 8 bit of data we are reading from this sensor, we are calling dist underscore low, and the next 8 bit, from bit 8 to 15, uh, we are calling it dist underscore h. So we have total 16 bit of value from 0 to 15. The first 8 bit is dist underscore L, and the second higher 8 bit is distance underscore h. As it's already, they already said it here. Distance L, distance value is low 8 bit, and these values we can get in we can get these values in decimal or hexadecimal format, but I would suggest you to read this data field as a character or any hexadecimal type. Basically there is no hexadecimal type, but you can declare the variable as a character to read the data, and during the printing, you can use %x to print the value in hexadecimal format, and you can observe the data. So as we have two fields of data, we need to merge them, right? Because if we use only the lower 8 bit, we can't represent a large value of distance, because we know the 8 bit, using 8 bit, we can only represent numbers from 0 to 255. For example, if the distance is more than, let's say, 255 centimeter, we need one more bit, right? So that's why we can't represent all the numbers using just only dist underscore L bits. We also need this distance underscore high, and we need to merge these 2 bytes to get a single unit distance value. We have also the other fields you can go over, but please try to remember we only need byte 3 and byte 4. And to understand which byte is distance low and distance high, we can add a condition, like if the first 2 byte is 59, basically it helps us to understand that the next byte is coming after 0x59 is byte 3, and the next byte obviously is byte 4. So let's go over our code. So in your main code, that is ECS388 underscore TFmini.c file, not the library file, we are already wrote the condition for you. So this serial read function, as we already discussed this serial read function in our previous lab, that is in lab 3. We know this serial read function can read the data from Rx data register. So what we are doing, this serial read, it is continuously reading the data from our LiDAR sensor. And if the value we are returning from that Rx data register is Y, so this Y is basically the ASCII character of 0x59. So basically each function call of serial underscore read is giving us byte by byte value of byte by byte value from the sensor. So first, if the first function call giving us y and the next function call also giving us y, that means we already read the value from byte 1 and byte 2. Now, if we call the next, if we call the serial underscore read function again, we know that we can access the value of byte 3, that is distance low. And if we call again, uh, that is serial read function, we are gonna get the value of distance from byte 4. Now, so as you can see here, we have to call the serial read function twice inside this if statement, and we can store these bytes, the value from this byte 3 and byte 4, and then we need to merge this two 8 bits to 16 bits to get our final distance. Now the question is how we can merge two 8 bits to 16 bits. The answer is we can merge them using the shift and OR operation. For example, let's say when we call the first serve read function call inside this if statement, we got, let's say, E8. And in the next function call, let's say we got 03. These values are in hex format. And if we convert the value into binary, we have this value. So we have these two binary values we want to merge. How can we merge them? We know the distance high is the most significant bits of this 16 bits. So what we can do, as we know, byte 4 is distance high bits. So we can shift it in 8-bit place. So if we can shift the byte 4 values to left shift 8, we know we'll able to add 8 zeros on the right hand side of this byte 4. So as you see, after doing the shift operation from here, we got this 16-bit of number. Now the byte 4 is 16-bit. And if we do the OR operation with byte 3, eventually we know all of the values are 0 here, and we're doing OR operation. So if is there any 1, we'll get exactly the same value as byte 3. So now after do the OR operation of byte 3 and byte 4, we can achieve the full distance measurement from our sensor. Now you can ask yourself two questions. The first question is, can we just add two 8 bits to 16 bits? I can give you some hints to think about this answer. So we can't just use the add operator for two 8 bits, because it will simply add that two numbers, but it will not merge them, right? So as a result, we have to do the OR operation. And the next question is, what type should I choose to save this two 8 bits variable? So you can choose any type. It's up to you. You can choose the type as an int or as a character. But please try to remember this. We have to choose the type that is only 8 bits. Because we know the data we are reading are 8 bits, right? So yeah, we know we have for example, unsigned uint 8_t that can that can only store 8 bits, or we can also use the character. We know by default character only can store 8 bits. So yeah, please try to go over the the codes and try to understand how you can read the data from byte 3 and byte 4 and eventually merge them. So it's pretty straightforward. You have to use the shift operation and the OR operation. And this lab is very easy to complete. I hope this was useful. Thanks. Thank you so much.